Assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. You know what's worse than hearing a news story about a website having its account database being completely hacked and all the passwords being leaked on the dark web? A complete list of billions, that's billions with a B, by the way, as in Bravo, billions of passwords from thousands of websites being freely available in plain text to anyone that wants it. Yeah, we got a big story to talk about today, but we also have an update to the long-awaited GitHub Copilot story, which I told you guys I'd keep you updated on, and it's been a while since we've had an update, but we do have an update, so we'll get to that in this episode as well. And I also wanted to revisit a conversation we had on our very first episode of the podcast about, is programming hard or difficult, or is it hard to write code? So that's coming up on this episode, but first let's start off with our trivia question. The four principal wireless encryption standards available at most access points are WPA, WPA2, WPA3, and which less secure fourth option? So what is the fourth encryption standard aside from, in addition to, I should say, to WPA, WPA2, and WPA3? And that is your trivia question for the week. So as I touched on at the very beginning of this episode, we have quite the story to talk about. So RockYou's.txt got quite the upgrade. So if you've played around with any sort of hacking passwords or password cracking or any kind of like hacking in general, or if you've used Kali Linux at all, you're probably aware of the file called RockYou.txt. So for the uninitiated, it's essentially a list of commonly used passwords. Specifically, the RockYou.txt from like Kali Linux is around 134 megabytes or so, and that's just a plain text file, and it's just a list of commonly used passwords. Now, why is something like this valuable or useful? So first off, hackers can use these word lists to compute rainbow tables, which if you've never heard the term rainbow tables before, or if you just need a refresher, essentially what a rainbow table is a pre-computed hash of passwords in general that can be compared against other hashes in a leaked database in order to figure out the password. So essentially, if you're a good designer of your database, you are not storing the user's passwords in plain text. You are encrypting them somehow, generally through the use of some kind of cryptographic hash algorithm. And the reason why this is done is because it's really easy to compute the hash, but it's assuming you're using a good hash algorithm, it's impossible to get what was put into the hash. So for instance, if you tried to compute the hash of, say, password, you would get a string of essentially hexadecimal characters or however you decided to encode it, but it would be almost impossible to reverse engineer that to get what was originally put in, which in this case is password. But the reason why rainbow tables are so valuable to hackers is because you don't need to worry about what the original password is because you already have that correlation. So if you already have a list of password hashes and their corresponding password, all you have to do is search the database dumps for these hashes, and then you already have the pre-computed, it's already been computed, so you already have the associated plain text password, so in essence, you know the password for that account. So if you actually want to know how any kind of accounts actually do and handle passwords, they don't do so we already established that if it's designed well, it will be encrypted in a database. And rather than decrypting the password and comparing the plain text password, all the program's doing behind the scenes is taking a hash of the password that you gave it and comparing that to the hash in the database. If they match, then the password's the same. If they don't match, then the password's incorrect. Now depending on the hash algorithm you use, you can run into instances where two different values can compute the same hash, but that's, of course, where you have to be making sure you're using a good hash algorithm. But anyway, so that's rainbow tables in a nutshell. The other thing that hackers can do with these word lists is just brute force attacks. So if there's no kind of gate around how many retries you can do of a password, the hackers, if they know the username, can just run the password through a list of an automated script that'll essentially run through every single password in this word list file until it finds a match, and then they can get in that way. So word lists are definitely very valuable to hackers when it comes to trying to take over accounts. And as we've already established, what I thought back when I was didn't know better, aka like a few minutes before the podcast when I discovered this, I thought the RockYou.txt file that came with Kali Linux, which as I mentioned is around 134 megabytes, I thought that was a massive word list with tons of passwords. But compared to this recent password dump, if you will, it basically looks like an empty text file with absolutely nothing in it. So 0 bytes. Because the new version, which has been dubbed RockYou 2024.txt, has a whopping 9,948,557,739 unique plain text passwords coming in around 160 gigabytes in size. So, yeah. About 1,000 times larger? I think that my math's right. Regardless, it's a heck of a lot larger than the one on Kali Linux. So yeah, almost 10 billion with a B unique plain text passwords in this single text file, and you can download it right now. So, yeah, but it also should be worth noting that this isn't the first time a large compilation of plain text passwords has come up like this. Now, it's the largest compilation to date, but the previous record was actually back in 2021 with 8.4 billion, so the hackers managed to find an additional 1.5 billion. Now, I make it a point to say unique plain text passwords because these aren't just like random strings that the hackers called passwords and threw it into a text file. Like they didn't go into they didn't write some like password generator program that creates a random string that's 15 characters long and is a random collection of numbers, letters, and symbols, and then threw it into a text file and called it a day. That's not what they did here. According to security researchers, the attackers developed the data set by sourcing from internet sourcing the internet for data leaks. So essentially, anytime you heard about, X site got its account database breached, or this other site had its passwords leaked, or whatever, they essentially collected all of those and got them that way. So in other words, these are real passwords that real people actually use. To quote the Cyber News article, which I will have linked down in the show notes below, RockYou 2021 compilation, which is an expansion of the data breach from 2009, includes tens of millions of user passwords for social media accounts. Since then, however, the compilation has ballooned exponentially. Most likely, the latest RockYou iteration contains information collected from over 4,000 databases over more than 2 decades. So, kind of as I mentioned, anytime there was a database breach for some website, those passwords were getting harvested and essentially compiled into this RockYou.txt file. So the Cyber News team that initially discovered it said, moreover, combined with other leaked databases on hacker forums and marketplaces, which, for example, contain user email addresses and other credentials, RockYou 2024 can contribute to a cascade of data breaches, financial frauds, and identity thefts. So, yeah, I mean, in all honesty, if there is a, I guess I shouldn't say if there is, because there is a file containing virtually 10 billion passwords that people are actually using or have used in the past, I mean, it's not unfathomable to think that, the hackers trying to hack into accounts are going to have an absolute field day with all the accounts they're going to be able to get into with all these passwords, running rainbow table attacks, running brute force attacks, whatever the case may be. They're going to have a field day with all of these passwords. So I suppose if you wanted to be uber safe about it, you could download this file and run it against all of your current passwords. So in other words, if you're using a password manager, which you definitely should be, you can essentially take the passwords in your password manager and basically do a Control F or a grep or whoever you want to search the file, which granted is probably going to take a while, seeing that it's over almost 10 billion unique plain text passwords. And if it's anything like the RockYou.txt file in Kali Linux, that's basically 10 billion lines. So it's going to take a while to search through all those. But if you wanted to, you could check all your passwords to see if they're in this new text file. And if they are, then you probably want to change that password to something that isn't in the text file. But with that said, I'm not exactly going to tell you how to download said file, but needless to say, if you do a tiny bit of internet searching for RockYou2024.txt, you will almost certainly find a torrent link to be able to download the entire file, and I will just leave it at that. So yeah, if you do happen to do this and, check all your passwords against this file, and you do decide to change them, you also kind of need to do another search to make sure that your new password that you changed it to is not actually in the list. So yeah, quite the story. Like I said, I will have the link to the Cyber News article down in the show notes below, so you can definitely give that a check after this episode. And with that, how about we move into this week's cybersecurity tip? For this week's cybersecurity tip, although we've touched on it before, I think it's fitting given the whole password talk we just talked about how to actually secure your accounts. So with this latest news about all these passwords that have been compiled into a single source, you better have some sort of multi-factor authentication on your accounts. rather than just passwords alone. Or you could have something like pass keys or certificates for your authentication instead of using passwords. But regardless, you should be doing some sort of multi-factor authentication. And the reason for this is, as we've discussed before, the reason why multi-factor authentication is so important is because even if an attacker can guess your password, or they have this RockYou 2024.txt file that they ran your account against and managed to get your password either through brute force or by a rainbow table or something, they still can't log into your account because they need that additional factor. Ideally, you have something like either a hardware key, like a YubiKey, or you have some kind of authenticator app, like whether that's Duo, Okta, Google, Microsoft, whatever your authenticator app of choice is. Ideally, you have something like that, or worst case, but still better than nothing, SMS. We've talked many times why you shouldn't use SMS because how it can be spoofed and there's security concerns with it and it comes in plain text, but it's better than nothing. But the reason why, again, like I said, you want to have that multi-factor authentication is because even if they try to, get into your account with your password, they're almost certainly going to get asked for that two-factor authentication method, because virtually any website would be smart enough to know that, hey, you usually log in from this IP address, which is located in the US, but now you're logging in from another IP address, which is coming from South America. Let me just make sure you are who you say you are. Verify yourself with your two-factor code, right? Now, of course, I just made that entire example up. For all I know, maybe you did just travel to South America and you got prompted for your two-factor, which is a good thing that you did. But just kind of goes to show there are security measures in place by companies in general to try to counteract fraud like this. Whereas if you didn't have multi-factor authentication, they would, assuming they got your password, they'd be right in. So let this story kind of be another wake-up call that passwords, no matter how good you think your password is, there's always a chance that your password can get leaked somehow or compiled into some kind of word list, and you need to be taking additional measures to make sure you keep your accounts safe. Now, like I mentioned, you can do this through multi-factor authentication, which you definitely should be doing. Another fantastic way is using some kind of password manager that can randomly generate unique passwords. I think it goes without saying you should not be reusing passwords for your sites. I know I've been guilty of that in the past, and I've been trying my best to get past that with a password manager. I think I've mentioned before on the podcast, personally, I use Bitwarden. I self-host it because I like that added peace of mind of knowing exactly where all my secure passwords for all my various accounts are. All that sensitive data, I know where it is. It's secured on my hardware, so I know it's not out in the ether somewhere that could potentially get hacked by some future data breach. But anyway, you should be, like I said, you make sure you're using multi-factor authentication, use some kind of password manager, and be sure to be not using the same password for more than one site. So that is your cybersecurity tip for the week. So now on to the GitHub Copilot update. So it's been a while since I've last updated you on this, and quite honestly, I don't remember when the last time I updated you was. I want to say it was at least a few months ago, if not close to a year ago. I honestly don't remember. It's been a hot minute. So in case you are either new here or you kind of forgot what this whole story is about, so the basic gist of this is developers noticed that when they were using GitHub Copilot, GitHub, which is GitHub and Microsoft's kind of AI assistant to help you write code. So they noticed when when it was quote unquote writing code for them, it was essentially copying code verbatim from open source projects and not giving any kind of reference to the source, and thus violating the open source licenses that some of these projects were using, so the allegations claim. Now, the judge in the California court where this case was going on has dismissed the case, writing the following. In sum, plaintiffs' claims do not support the remedy they seek. Plaintiffs have failed to establish as a matter of law that restitution for any unjust enrichment is available. As such, measures of the plaintiffs' damages for their breach of contract claims. And the judge went on to state that, quote, court dismisses plaintiff's section 1202B claim at this time with prejudice. The court declines to dismiss plaintiff's claim for breach of contract of open source license violations against all defendants. Finally, the court dismisses plaintiff's request for monetary relief in the form of unjust enrichment, as well as plaintiff's request for punitive damages. So, legalese aside, this case is pretty much dead. Now, I do want to point out the fact that they did say that the court declines to dismiss the plaintiff's claim for breach of contract of open source license violation against all defendants. So, in essence, I'm no lawyer by any means, but my reading of that essentially seems the court isn't kind of waving their hand away at the claims that GitHub Copilot was indeed violating the open source licenses, and is maybe giving some validity to that claim, essentially. But the case as a whole is essentially being thrown out. So it seems like this isn't going to go anywhere. So, I mean, there's still, I guess, the hope, because they didn't dismiss the claim that Copilot potentially violated open source licenses. But at least with this case, I think it's safe to say it's probably not going to go anywhere. But there's maybe the chance that they could make another claim or something. I don't know. But it is kind of interesting to see. This was definitely a story I wanted to follow, and it might not necessarily be the resolution that some people wanted to see. I think it's at least nice that we finally got a resolution to this, because especially with how long it's been since we got the last update. So we'll have a link to an article kind of discussing this latest change in the show notes below as well. And with that, let's get into what nerdy stuff have I been up to this week. So I think at this point, I have finally drank the Kool-Aid that 3D printing is a core part of home labbing. And so depending on where you get your home lab fix from, where you kind of look for ideas or kind of get inspiration from, there's a decent chance that you'll probably have come across someone or multiple people using some form of 3D printing to do something with their home lab. Now, I recently acquired a 3D printer myself, and I was looking for kind of projects to use with it, because of course whenever you get a new toy, you want to play with it and you want to try to find all the various kinds of use cases you can use with it, and the 3D printer was definitely no different here. So the home lab use case that I came up with, which I think is probably going to be the first of many, I would say, but the first use case I found was, so I guess before I get into the use case, let me back up and give some context here. So I'm pretty sure I mentioned on the podcast, but in case I didn't, a few months, maybe even over a year ago, I don't remember when it was, I had bought a PoE or Power over Ethernet hat for my Raspberry Pi. And if you're unfamiliar with what that is, basically it's a little daughter board that plugs into the Raspberry Pi's GPIO pins, or general purpose input output, as well as the power over Ethernet pins specifically for the Raspberry Pi, so it kind of sits right on top of it. And it allows you to plug a Ethernet cable into the Raspberry Pi, which gives it networking and also gives it power. You of course have to have a special switch that supports power over Ethernet, but since I have one of those, I decided it was a lot cleaner of a solution to do power over Ethernet, because then that was one less power cord that I had to run in my server rack. So I kind of like the clean aesthetic that it gave. But the one issue that I have been dealing with the power over Ethernet hat is the case that I had for my Raspberry Pi no longer worked, because the case had like some internal, I don't know if it was for structural rigidity or what the purpose was, but it kind of gave some wording for like what the various components were, and kind of anyway, point being, putting the PoE hat on the case on the Pi made the case no longer fit. The only part that kind of worked was the very bottom portion, which I still used because I didn't want the Pi touching the metal of the server rack or the switch and potentially causing a short. So for those reasons, I had it at least sitting on that. But I had wanted at some point to find some kind of solution for the Raspberry Pi, and I found the perfect solution with my 3D printer. So I decided to 3D print my own Raspberry Pi case. Now, when I say print my own, I didn't actually make the model myself. I found it on Thingiverse and printed it, but the point is, I used my 3D printer to print a case for my Raspberry Pi, and I have to say, it looks pretty darn cool. I was able to, so because it came in like two pieces, it was really easy to print in a couple different colors. So I have like the bottom is in black and the top is in red, and the top has this like super cool like honeycomb, like raspberry kind of cutout, if you will, for like, so it has like airflow and also kind of looks like a raspberry. So personally, I think it's pretty cool. So yeah, that was kind of one of the things that I got up to this week. In other news, I had talked about last week about me making a port of my Elite encryption algorithm that I wrote, porting it over to the Swift programming language. So this week, I kind of beefed up the error handling of it. So I had mentioned last week that I got the encryption and decryption working, and I got reading and writing to files working, so essentially being able to read in a file, encrypt it, or I guess not read in a file and encrypt it, but read in a file to decrypt it, or reading, or essentially encrypting and decrypting files. But one of the things with that solution was I wasn't exactly handling errors in the best way. I mean, I was technically handling them, but I was essentially doing it, you could say, the C way, which essentially just returning values corresponding with, what happened. So I decided to actually make use of Swift's ability to throw exceptions and catch exceptions and whatnot, and pretty much add a bunch of those in for all the various ways that different aspects of the program could potentially fail. So if the write failed, if the read failed, if the program failed to properly convert to base 64 encoding, or whatever the case is, just came up with a bunch of potential exceptions and threw them as necessary and caught them and printed that out, and kind of really cleaned up, I guess, the implementation of what I had so far, and just made it a little more robust. But the other thing that I got working was the key generation. So that was one of the things kind of on my to-do list for this program, was to get the key generation working, because, I mean, it's kind of hard to make use of an encryption algorithm that uses keys if you don't have any keys to use. So I got that working, and one of the, I guess, not necessarily hurdles I ran into, but it's kind of a byproduct of this. Swift has the ability to essentially create what they call a package.swift file, which essentially it will for a couple things. It does a couple things. First off, it allows you to specify any Swift dependencies that aren't like natively included in like the standard library, if you will. So for the key generation, I had to make use of the crypto kit, or Swift crypto, I think is what the GitHub repo is called. But that's not like a natively installed package, so I had to create this package.swift file to essentially be able to ensure that dependencies pulled down and linked properly. And kind of as a byproduct of this, the other cool thing with this package.swift file is if you have it, you can use the native Swift command, I guess. I'm not exactly entirely sure what the proper term for it is. But rather than what I was doing before, which was using the Swift compiler or Swift C, I could just use Swift build, and it would essentially build the entire project for me because it had this package.swift file, which was honestly super cool and made for seamless builds, which is pretty spectacular. It puts it all in a separate build directory, so it makes cleaning everything super simple. But I did keep the make file just because I like using make files, but essentially just made the make file to be a glorified wrapper for the various Swift build commands. One for like building a debug version, a release version, building and running at the same time, and kind of things like that. So I think at this point, pretty much all of the core components are really in place, because we got the key generation working, we got the encrypting working, we got the decrypting working. We can read from files, we can write to files, so we can read in files, encrypt them, and write them back. So pretty much all the core functionality is there. I mean, there's maybe like a couple minor things like, parsing a directory tree, and that kind of a thing for encrypting directories. But really the core functionality is already there. So since I got that, I've kind of started the initial process of also working on the user interface, which really isn't much of an interface. It's a command line program at the moment. I don't think I'll plan to make this version have a GUI. Partly because I'm not entirely sure the compatibility of Swift UI with other platforms that aren't, Mac OS. It is something I should probably look into, but also I think command line interfaces are a lot easier to implement than GUIs. But also that's just my kind of bias, since I've never been the best at making GUIs. If you've seen the Java implementation of the Elite encryption algorithm, which was the first one I made, the GUI is quite rough, I would say. Now, don't get me wrong, it is completely functional. It's totally functional and works as you'd expect. It's just not pretty to look at, is the thing. But, it gets the job done. Which I guess is really all that matters. But anyway, that Java version also technically lacks some features because it doesn't have the ability to decrypt entire folders. It can only do a single file at a time. And it also doesn't really encrypt your keys, which the C version does. Which I probably could fairly easily add into the Java version. I just kind of never went back and did it. The Java version essentially just serializes the keys using the serializable thing in Java. But anyway, we're kind of getting off track here. The point is, so I started working on the user interface for the Swift version, and it's honestly hasn't been all that difficult, since essentially what I'm doing is I'm just taking the interface that I created for the C version and essentially copying it over to the Swift version, since I kind of liked that interface. It kind of gave you just the options as numbers, so there really wasn't a whole lot of user input to mess with, because if you've listened to the podcast for long enough, user input is basically the worst thing that's ever happened to computer programs because of all the various exploits that come through user input by not parsing it correctly. So if you can greatly minimize what's coming into your program, you have a better chance of not getting hacked. We'll just put it that way. And it's a lot easier to ensure that you cover all of your bases if you know that you're only dealing with numbers, since you can essentially just do a check. Is this a number? No. Okay, throw it out. And you don't have to necessarily worry about, am I getting an SQL injection right now? Or am I going to get a buffer overflow or something like that? So in my opinion, it's a lot easier, one, to deal with user input, but two, also to protect yourself from potential funkiness that goes on when user input gets involved. So that's the main updates there. I also discovered, which is how I virtually discover all the bugs in my programs, a bug with my CPU benchmark. Now, this has been kind of an ongoing saga on the podcast off and on, where every now and then I try to run the benchmark, or the API, which I called it the CPU benchmark API, which essentially just goes to cpubenchmark.net and pulls down like information from the site. It's basically a glorified web scraper. But there was kind of a saga like maybe a year ago or so, where it seemed like whenever I would implement a fix to fix something that didn't work, and then they would change how they did the code on their site so it would break the web scraper, so then I'd have to, change some things to get it working, and it was just kind of like this back and forth thing for a while. And then I got it working again, kind of never touched it for a while because I didn't really have any new CPUs to add. But then I finally got back around to adding some of the new CPUs that I've added to my collection. And I noticed that when I ran the script, I looked at the overall scores and the single-threaded scores, and it was NA. And I was like, well, something didn't work. So then I, did some investigative work and found out that the code that they used for their site changed yet again. So I fixed that issue, so I actually got it pulling the correct data now. So now it's fixed, at least for the time being. I guess we'll see how long this fix lasts. But yeah, so that's something that's I've been fighting with them for a while, since they keep changing their site on me every now and then, which I guess I can't really blame them. But yeah, that is one thing when it comes to using a web scraper versus actually using an API directly. If you're using an API directly, you don't necessarily have to worry about them changing the UI of their website. But if you're using a web scraper, you do, because if they change how elements are displayed, it kind of breaks things, as we've seen. But the reason why I'm doing the web scraper is because, at least as far as I can tell, there's no actual API for cpubenchmark.net, so I decided to sort of write my own by making a web scraper for it. So that was those updates. So I guess to kind of wrap up this episode, I wanted to touch on a topic that we covered in our very first episode of the Dark Assassins podcast, which essentially revolves around this idea of, is programming or software development or software engineering, is it actually that difficult? And if you didn't listen to that very first episode of the podcast, essentially the TLDR that I arrived to, or the too long didn't read, or since this is a podcast, I guess it'd be TLDL, too long didn't listen. Once you break down whatever your project is that you're trying, or problem is that you're trying to solve, it becomes fairly easy. And I know that word easy comes with a lot of weight to it, because this is coming from someone that has been writing code for almost a decade now. So I understand that my thinking that programming is easy for someone that's been doing it for a long time is definitely different than someone that's either never written code before, or has never seen code before, or is just learning to write code, or something like that. But the reason why I kind of came to the conclusion that it's not all that difficult once you break it down is because, in essence, if you take a very complex, large problem, you can, if you're using some kind of like object oriented design, you can basically break down the various components of that problem into objects, and then you can continue to break those components down into smaller and smaller pieces until you get to what's known as primitives, or like the core variables that are in every single language, like your ints, your floats, your doubles, your characters, that kind of a thing. So if you can eventually break everything down, like the easy one that people always go to when they're talking in like textbooks or whatever is you have a person, right? Like, how do you represent a person in code? Well, first you kind of have to identify things about people, right? Like, people have an age, they have a name, they have a height, they have a weight, things like that. And how do you actually represent those things? Well, you can represent a name as a string, you can represent an age as an integer, you can represent a height depending on how you want to classify it as either an integer, or you can maybe do like a float or a double if you want to have decimal values. Same thing with a weight too. And then you see, just by in a matter of how long did that take us? A few seconds. You broke down this complex idea of a person into first an object, which is the person object, and then you broke that down even further into the primitive types that create that person. So, and then you could, scale that up, right? If you have a class of students, you have a lot of students. Okay, I have this entire class full of students. Well, every student is a person. We already established how you break down a person. So now you can essentially break down a class into a bunch of different people, and we already established how you break down a person. So that was kind of the argument that I gave as to why programming and software development isn't necessarily as hard as it seems. But the reason that I wanted to revisit it this week is we are in that time of year where it is the summertime and college kids are looking for jobs or internships. And over the past month or so, maybe month and a half, I've had a few different conversations and interactions with younger college kids, like interns age or so, that aren't computer science majors, but they're cybersecurity majors. So they are required to at least have some kind of computer science background, because if you're going to go into cybersecurity and learn how to protect against things like various vulnerabilities, you kind of need to know how those vulnerabilities are created. So you kind of need to know at least the basics of how to write software in order to understand various kinds of software vulnerabilities. But in talking with some of these interns, they mentioned to me how they found coding to be difficult, or they found coding wasn't easy, or it was hard, or something to that effect. Now, like I said, for someone that has been coding for close to 10 years at this point, I was kind of taken aback, because to me, coding is pretty easy. I do it in my sleep. Well, maybe not really, although sometimes I guess you could argue I do code in my sleep, since every now and then I do have dreams where I'm literally writing code in my dream, which, weird, I know, but it happens. I've also heard stories from people that, famously, I had a professor, I think in college, that had told us a story about, sometimes he would be, asleep, and then he would be ajar, woken up at some ungodly hour in the middle of the night, and had this eureka moment, and ran to his computer and started writing the code that he came up with while he was sleeping. But point is, I code for fun. I enjoy coding. I do it all the time, and don't think it's necessarily all that hard. So hearing other people say that it's hard is, not something I'm used to hearing, because of course I'm living in my own bubble where I like coding and coding is easy. But anyway, Some of the complaints that they were kind of giving was the syntax problem and how hard it is to learn the syntax. Like, one of the arguments was, yeah, if I look at code, I can understand what's going on, but if I'm, forced to write code, I kind of struggle because it's hard to understand the syntax. And specifically, one of the examples that this individual gave specifically was, they liked coding in Python, but other languages like Java or C++, they weren't really a fan of because it was harder to understand. And I have to say, I guess I'll say this. I understand where they're coming from because if you have ever taken or even seen any kind of pseudocode, which essentially is the basic steps of how a portion of code will work without actually being implemented correctly. If you look at pseudocode and you look at Python, they're not one-to-one, but they're pretty close. There's kind of a joke out there that I've heard where Python is literally pseudocode because, the syntax for it or the grammar of the language. So like in most, and I don't know about most, but in a lot of languages that I've used, if you're doing any kind of like Boolean comparisons, like if you're checking to see if, one value is true and other value is true and whatever, if you're doing something like an if statement like that, you would say, let's say, if valid password and valid username, then, log in, right? So in the languages that I'm used to, that and statement, you do 2 ampersands, like the logo on your keyboard, the ampersand, the value above the 7, ampersand, ampersand. But in Python, you literally just type the word and it's the same thing with or too. So it's very easy, or I guess easier, for someone that's not doesn't have programming experience to kind of learn the syntax, because it's a lot closer to English how Python writes and reads compared to another language like Java or C++, for instance. But the reason why I only said I understood where they're coming from is because I had a very different upbringing, I guess you could say, when it came to my programming background. So I know I've touched on this before, but the first language that I ever learned was Java. And people have mixed feelings about Java. I've gone back and forth on it. But Java has a very C-style syntax, if you will. So it's very similar to C and C++. I think also like C#. JavaScript's fairly similar. Swift's also kind of similar. They have this kind of similar syntax where, like, functions and sections of code are kind of bracketed with brackets. Java's also object-oriented, but so is Python. But I think the reason why it was easy for me to pivot to other languages was because I had that Java initial experience. Because the thing with Java is the syntax is a big portion of it. So in addition to learning, programming concepts like, variables, algorithms, data structures, all that good stuff, object-oriented programming, I also had to kind of get ingrained in my head, all the various syntax things of Java, like making sure I have my semicolons and making sure I have my squiggly brackets and my square brackets and all my parentheses in the right places and all this good stuff. And then it made it fairly easy to translate that to other languages like C and C++ and even Swift to a lesser extent, because the syntax is very similar. They use very similar conventions when it comes to the syntax. Things like switch statements, if statements, while loops, for loops, a lot of it is very similar compared to those various languages. Now, Swift's different on how it does its for loops specifically. Its for loops are a lot closer to Python, I would say, than compared to Java. or C and C++. But when trying to learn C and C++, I didn't really have to worry about the syntax or some of those core functions of the language because it was very similar and almost one-to-one compared to Java. So once you actually got into, the more advanced classes where you start using, languages like Java, C++, and C and that kind of a thing, it was a lot easier for me to pick those languages up because I wasn't having to worry about learning syntax. Whereas if you start off with Python's fantastic for learning programming in large part because you don't have to worry about syntax. Because when I first started, like I mentioned, using Java, I pretty much got the double whammy because, now I'm not trying to brag and say, oh, I had it harder than the kids these days, because Python was definitely around when I first started learning programming. That's just not what the class I was taking was teaching. So, but the thing is when you first learn how to code, you're not only learning, the fundamentals of programming, like, I mentioned object-oriented programming if you're doing that, data structures, algorithms, data types, all that good stuff. You're also learning the syntax. But if you don't have to really worry about syntax that much, like, say, with Python, it kind of becomes an afterthought, and then when you move into other languages, you're like, why doesn't my code work? Because there's all this syntax stuff that you didn't necessarily have to worry that much about. Whereas if you do start off with a language like C or C++ or Java, you kind of have to learn both at the same time. You have to get that syntax and you have to get the kind of the core concepts. But specifically for syntax, it's, if you're kind of wishy-washy on what that really means, you can kind of think of syntax as the grammar of the language. So, like in human languages, we have these concepts of nouns and verbs and adjectives and punctuation and all that stuff that you kind of combine together to formulate sentences, right? So it's a very similar thing with programming too, where you have things like your curly braces if you're doing that to specify functions, and then you have things like semicolons or parentheses to kind of differentiate what things should be grouped together or what defines the end of a line of code or things like that kind of define and structure the language. So just like with human language, you can't pick up a new language and become fluent in a day or even a week or a month. It takes a while and a lot of practice in order to become, fluent in these languages, even with programming languages. Now, I think depending on the human languages you're learning, my understanding is that once you learn one language, like specifically kind of, I think it's the the Romance languages, like your Spanish and Italian and those kinds of languages, where once you kind of learn one of them, the other Romance languages are very similar in the sense that it's kind of easier to pick them up because, some of the verbs and whatnot are similar. So that would be kind of what I would kind of consider like the C style of languages, where like if you learn C or Java or C++ or C# or something like that, the syntax between all those languages is very similar. It's just kind of like the little intricacies that you have to pick up along the way. Whereas like Python is kind of its own thing and has a completely different syntax or completely different grammar. So the main thing that you really have to focus on though when you're learning programming is you have to focus on, really understanding those fundamentals, because that is what makes it easier to jump between languages. Because if you don't know how to implement something, it's going to be a lot harder to search how to do it than if you already know what you're trying to do. All you have to do is, how do I do XYZ in this language? You don't have to like kind of do the fumbling through of how you even achieve that task in the first place. So really, all you have to do once you're trying to move over to a new language is you're not trying to understand new concepts or anything like that. You're just trying to understand the new syntax of the language. So it becomes a lot easier to kind of figure out what you're trying to do and ask questions or search things online accordingly. So some examples that I have of this is if you kind of already have some concepts of programming, you could get a result quicker. So for instance, asking how do you use a dictionary in Swift, you're going to get a lot better results a lot faster than if you ask something like how do you process data only caring about unique values in Python. So the one is kind of you already know what you're looking for, in this case a dictionary, and you're asking how you do it in the language. Whereas the other one, the Python one that I just mentioned there, like you kind of know like conceptually what you want, but you don't know, like as far as programming goes, like what kind of data structures you need to use in order to reach the solution you want. So you'll probably still eventually come up with the solution you need, but it's not going to be nearly as quick. Because you don't already know that you want to use a dictionary for your solution, so you kind of have to figure out that that's what you want to do and then figure out how to implement it. So another kind of implementation of or example of this would be like this: how do you use a dictionary in C++? And if you search that, you'll instantly get responses and results for how to use a map, which is C++ version of a dictionary. But you kind of need that knowledge of, I want to use a dictionary, but I want to use it in this other language that I've never used it in before. And then if you already know that, it becomes a lot easier to search for the results you're looking for and actually get good quality results for what you're looking for and be able to implement it and then be able to, pick up and learn that language a lot quicker. So I guess to get back to the point here, is coding hard? Now, obviously, I'm very biased in this because, as I mentioned, all the years that I've been programming for. But my best way to kind of be objective in this is if you have an analytical kind of brain, or you're someone that, given some kind of problem of any kind, can come up with a solution for that problem and figure out how to solve it, I would say you can become a very competent programmer, because I'm pretty sure I've mentioned it on the podcast before, but in my humble opinion, at the end of the day, the vast majority of programming and software development and software engineering in general is how good of a problem solver are you. Because yes, you need to understand how to write code and the syntax of languages, but at the end of the day, those abilities to understand concepts and, syntax of languages won't do you any good if you don't know how to use them. And the way you know how to use them is by understanding how to solve problems. So, for instance, if you are given a string of text from a user and you have to do something with it to manipulate the string, if you don't understand the problem you're trying to solve, it doesn't matter that you know how to split strings and strip the white space off of them and do things like that if you don't know what you're trying to do with it at the end of the day. So I would kind of argue that if you know how to solve problems and are a good problem solver, I would say you're probably about 3/4 of the way there to being a very solid, competent software engineer or software developer. And then I would say another like 20% of that is understanding the programming concepts, because of course, if you can solve problems, you have to know how to implement them in code. So you need to know things like how do you iterate through arrays, how do you search through binary trees, how do you sort things, how do you use data structures, those kind of core programming concepts. You of course need to know those, but like I kind of mentioned, they don't do you much good if you don't know how to solve problems. So, and then of course, kind of the last little, I guess like 5% or so is actually understanding the syntax of the language. Because of course, if you don't understand the syntax of the language, you can't actually write the code to implement the problems that you're trying to solve with the data structures and algorithms that you know. So that's kind of, I guess, my breakdown of programming and software engineering and all that good stuff. So at the end of the day, if you are a good problem solver, I would say, while there might be some roadblocks, at least initially, kind of like, doing anything for the first time, you stumble at first, and then eventually over time you pick it up. I would say if you're good at problem solving, programming is something that you definitely probably will be able to do. Like I said, it might take you a little bit to kind of get your feet wet and kind of get your foot in the door of understanding kind of like the language and stuff. But I think probably the main hurdles you'll kind of run into is some of those syntactic things. Missing semicolons, forgetting curly braces, all that fun stuff. So yeah, that was, I guess, something that I kind of wanted to revisit. I'd be interested to hear your thoughts on this. If you're a new programmer, if you've never written code in your life, if you've been writing code for 20 years, wherever you are in the spectrum, I'd be interested to hear your thoughts. You can send me an email at contact@darkassassinsinc.com, or you can leave a comment down below if you are on YouTube. And before we wrap up for the day, I think we should get back to our trivia question, which is the 4 principal wireless encryption standards available at most access points are WPA, WPA2, and WPA3, and which less secure 4th option? So what is that 4th option aside from WPA, WPA2, and WPA3? If you said WEP, congratulations, you got this week's trivia question correct. And I think with that, that's probably going to about do it. So if you enjoyed the episode, leave it a rating and review, and subscribe if you haven't done so already. And be sure to share with a friend or family member, especially with that whole password breach thing we got going on, all those plain text passwords out there in the ether. And if you have any questions about this episode, or you have any comments or topic ideas for future episodes, be sure to shoot me an email at contact@darkassassinsinc.com, or if you're on YouTube, you can just leave a comment down below. And with that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.